So imagine you've got an AI customer service bot. It absolutely needs to be concise, get straight to the point.
Right. Quick answers.
But then you've also got an AI research assistant, and that one needs to be super detailed, explaining every little nuance.
Totally different needs.
Exactly. So how on earth do you teach an AI to do both? Or really any specific preference you might have without, endlessly retraining it from scratch every single time?
Yeah, that's the big question.
Okay, let's dig into this. This deep dive is all about a really groundbreaking development in AI. Principle following reward models.
Hmm?
We're going to unpack why current large language models, LLMs, often struggle to really get and adapt to all the diverse, sometimes really subtle human preferences we have.
And crucially, we're looking at a new approach, something called RewardAnything.
Right. RewardAnything. The idea is to make AI alignment more flexible, transparent, and way more efficient, moving beyond these sort of rigid, hidden preferences we've been dealing with.
It's a big shift.
Our insights today come from a key research paper. RewardAnything, Generalizable Principle Following Reward Models. It's from Peking University and WeChat AI.
Some heavy hitters there.
Definitely. So, consider this your fast track to understanding the cutting edge, how we might finally teach AIs to genuinely understand what we want.
Okay, so to really get why this is such a breakthrough, we kind of need to start with a foundational challenge, right?
Makes sense. Where do we begin?
Well, in the world of LLMs, you have these things called reward models, or RMs. They're essential. Think of them as guide rails.
Guide rails,
Yeah.
telling the AI what's good or bad.
Pretty much. They act as proxies for human preferences, especially in techniques like reinforcement learning from human feedback, RLHF. They're effectively saying, yeah, this response is good, or nope, that one's not.
So they're the AI's internal teacher, basically, grading its work.
Exactly. But, and this is a big but,
Yeah.
there are two major problems with how these teachers currently work.
Okay, what's problem number one?
Problem one is their limited generalization and adaptability. See, current RMs, they're trained on static, fixed preference data sets.
Static, meaning they learn one thing and that's it.
Pretty much. It makes them incredibly rigid. They learn one specific preference, let's say, for helpfulness, but then they just can't adapt easily when you need something else. Like you said, brevity for a chatbot versus detail for a researcher.
Oh, okay.
A traditional RM really struggles to give different scores for those scenarios, even with the same prompt and responses, because it's only ever learned one definition of good.
So it's like teaching someone only multiple choice tests and them being shocked they can't write an essay? That sounds like a huge headache for practical AI use.
It is a huge headache. Think about the practical side. Every time you need the AI to shift its style casual chat to formal explanation, whatever you're talking about, collecting new human preference data.
Which is expensive.
Hugely expensive and time-consuming. Retraining these massive models, it burns through resources that's just not scalable or sustainable, especially with how fast AI moves.
Right, it seriously limits how dynamic AI can be. Okay, so that's rigidity. What's the second big problem?
Well, that leads us straight into bias and a real lack of interpretability.
Interpretability, meaning we can't tell why it prefers something.
Exactly. Traditional RMs learn implicit values. They see the outcome this response was chosen, that one rejected, but they don't get the reason why. No explicit rationale.
So they might learn the wrong lesson.
Precisely. They often infer values through what we call spurious correlations, like maybe longer responses happen to be chosen more often in the training data.
Even if the real reason was accuracy, not length.
Right. The RM might mistakenly conclude that length itself equals quality. It's like a student thinking a longer essay must be better, even if it's full of errors.
Wow, okay, that's a massive issue. If the AI's own teacher is biased like that, how can you trust it? And without knowing the reasoning, it must be almost impossible to explain or predict its behavior reliably.
It absolutely limits reliable alignment. You're often left guessing. And this lack of transparency, this rigidity, that's exactly where this new idea comes in.
Okay, so the old way has problems. How do we fix it? This is where the principle following idea comes in, right?
Yes, exactly. It's a real paradigm shift. The core idea is moving towards principle following reward models.
Principle following, meaning they follow instructions.
Explicit instructions, yes. Instead of trying to guess preferences from static data, these systems adapt dynamically based on natural language principles you give them.
Okay, hang on. It's similar to how instruction following was a huge leap for LLMs themselves, letting them do complex tasks without specific retraining.
That's a perfect analogy. The goal is the same for reward models.
Yeah.
Make them flexible tools that generalize across different preference contexts without needing task-specific retraining every time.
So you just tell the reward model what principle to follow.
Essentially, yes. Formally, the task looks like this.
Yeah.
You give it a natural language principle like be concise and factual. You give it a prompt and some candidate responses.
Okay.
And the model produces an evaluation score for each response, showing how well it adheres to that specific principle. And crucially, it needs to work for principles it's never seen before.
That's the generalization part.
Exactly. And to make this systematic, the researchers categorized principles into 5 key areas.
5 categories. What are they?
Right. So first, there's content. An example principle might be encourage detailed responses with relevant examples. They curated about 29 of those.
Okay, content. Makes sense.
Then structure, like value responses with clear, organized information flow, around 53 examples.
Structure, yeah, logical flow.
Third is tone. Maybe give responses with an encouraging and helpful tone, higher scores, about 36 examples.
Tone,
No.
friendly, formal, etc. Got it.
Fourth, logic. Something like good responses should demonstrate coherent thought processes. They had 35 of those.
Logical reasoning. Check.
And finally, style. For example, favor responses using clear, concise language without jargon. Around 47 examples.
Style, like being formal or informal, simple or complex language.
Exactly. In total, they carefully curated 200 distinct principles, each one designed to be clear, specific, and actionable for the AI.
Wow, 200 principles across those 5 categories. That's incredibly thorough. It sets a really high bar. But how do you actually measure if a reward model is genuinely following these principles, especially new ones it hasn't seen?
Yeah, that's the million-dollar question, isn't it? And that's precisely why they developed RayBench.
RayBench, a new benchmark.
Exactly. RayBench is specifically designed to rigorously test this principle-following ability. Existing benchmarks just assume everyone wants the same thing, homogeneous preferences, which totally misses the point here.
Okay, so how did they build RayBench? What makes it different?
Well, first, they selected 50 distinct principles just for evaluation ones not used during any training.
So completely new territory for the models being tested.
Right. Then, for prompt, they used the existing RewardBench dataset, which covers lots of different areas: chat, math, coding, safety.
Diverse prompts. Good.
And to get responses, they used 10 different LLMs from 6 families, think GPT, Claude, Lemma, and instructed them to try and follow the given principle. This gives you a really rich mix of responses, some nailing the principle, others not so much.
Okay, so you have prompts, principles, and responses showing varying adherence. What about the correct answers, the ground truth?
For ground truth, they used 4 other state-of-the-art LLMs as judges: Claude 3.7 Sonnet, GPT 4.1, DeepSeek v3, and Gemini 2.5 Pro.
Using LLMs to judge other LLMs. Interesting.
Yeah, these acted as independent evaluators, giving scores 1 to 5 and rankings for each response based on the principle.
But wait, even powerful LLMs might disagree sometimes, right?
Yeah.
How do you get one solid ground truth if the judges don't always agree?
Great question. They anticipated that. They developed a clever consensus algorithm based on dynamic programming.
Okay, what does that do?
Essentially, it looks at the rankings from all 4 AI judges and finds the most robust, best to worst order, where at least 3 out of the 4 judges consistently agree on the relative quality between pairs of responses. It's like finding the strongest agreement among a panel of experts.
So it filters out the noise and finds the reliable consensus. Smart. Did they check if this consensus actually made sense?
They did. They had human annotators independently evaluate these consensus judgments. And the agreement rate was really high, 89%, with a solid Cohen's kappa score. It shows the algorithmic consensus was reliable, even for subjective stuff.
Impressive.
So overall, RayBench ended up with over 1,000 validated preference rankings, which translates to something like 31,000 traditional preference pairs. It's a serious benchmark built for this specific challenge.
Okay, that benchmark sounds incredibly solid. So, faced with RayBench, how did they actually design RewardAnything to meet that challenge? What's the secret sauce?
Right, RewardAnything itself. It's a novel reward model architected specifically to interpret and follow these natural language principles at inference time. That's key.
At inference time, meaning when it's actually doing the evaluation.
Exactly. And it doesn't just spit out a number. It generates a structured output, including explicit reasoning for its evaluation, the scores for each candidate, and a full ranking.
Reasoning too, that's different from just a score.
Totally different. Traditional RMs usually learn one hidden preference and just give you the score. RewardAnything explains itself.
How did they train it to do that?
They used a reinforcement learning technique called group relative policy optimization. or GRPO.
GRPO, okay, what's the core idea there?
Instead of just predicting a single score accurately, GRPO teaches the model to understand and evaluate the relative quality of a whole group of responses against a principal. It learns by getting feedback on how well its grading matches the ground truth ranking. It's more about relative comparison than absolute scores.
So it's not just guessing a number, it's learning to rank properly, like a teacher applying a rubric across multiple essays, understanding the relationships between them.
That's a great way to put it. It is about understanding relationships. And a huge part of its success comes down to the custom reward function they designed for its training.
Ah, the reward for the reward model itself. What did that focus on?
It had two main parts. First, the format reward. This basically incentivizes the AI to produce evaluations that are comprehensive, well-structured, and consistent.
Rewarding good form for its explanation.
Precisely. It checks. Is there explicit reasoning? Is the output valid JSON? Are all the required bits of information there? Are the scores and the ranking consistent with each other? Stuff like that.
So it's teaching the AI not just to have an opinion, but to express it clearly and usefully. That seems critical for transparency.
Absolutely critical. Making the AI's evaluation process interpretable is key. The second component is the accuracy reward.
Okay, how well does it match the ground truth?
Yes, but with nuance. It's not just about getting scores exactly right. It's about understanding how wrong an evaluation is.
What do you mean?
Well, for instance, it uses a weighted reversed pair penalty. Misranking a really great response, score 5, with a terrible one, score 2, is penalized much more heavily than, say, mixing up two okay responses, score 2 and 1. The bigger the true quality gap, the bigger the penalty for getting it wrong.
Ah, okay. So it learns that some mistakes are worse than others.
Exactly. It also encourages the model to use the scoring scale, like 1 to 5, consistently, gives partial credit for scores that are close, and looks at overall ranking agreement using measures like Kendall's tau. It's a really sophisticated way to measure accuracy.
So putting it together, this reward structure teaches RewardAnything not just to mimic scores, but to really understand relative performance, grasp error severity, and explain itself clearly through reasoning. That feels like a massive step towards AI we can actually trust and use effectively.
Yes, it's teaching it the why in a way we can understand. And for generating the training data for RewardAnything itself, they used a similar process to RayBench, but kept things separate. They used a completely distinct set of 150 principles, no overlap with the 50 used in the RayBench benchmark. And the prompts came from a different, entirely synthetic data set. No human verification on this training set.
Okay, so the training data was separate from the test data. How much training data did that result in?
It resulted in about 4,000 training examples, which corresponds to roughly 173,000 traditional preference pairs. So a decent amount.
All right, so they built this advanced model, RewardAnything, trained it with this sophisticated reward system, and they had the tough RayBench benchmark ready. How did it actually do? What did the experiments show?
The results were pretty compelling. First, they tested it on RayBench, an existing benchmark known for its tricky hard setting.
Right, the one that probes for biases.
Exactly. And RewardAnything achieves state-of-the-art overall performance, especially shining on that hard setting.
How so?
While that hard setting is where traditional models often mess up, they might prefer a long, nicely formatted answer that's actually wrong over a short, correct one.
Because they've learned that spurious correlation like longer is better.
Precisely. But here's the kicker. When they gave RewardAnything a clear principle like accuracy only, or prioritize accuracy over length, its performance on that hard setting just surged up to 82.5% and 81.6% accuracy.
Whoa. So just by telling it what matters most, using a principle, you can directly counteract those ingrained biases. You're basically giving it explicit instructions to ignore bad habits it might have picked up. That feels huge.
It really is. It validates that explicit principles can manage and mitigate those biases. You're telling the AI the why, not just showing it example.
That's like giving it core values to follow. Okay, so this brings up a really interesting point. What makes a good principle? Does the way you phrase it matter?
Absolutely. The research looked into this directly. First, goal prioritization. Ambiguous principles, like saying length should equal accuracy, actually led to lower performance.
Yeah.
The model gets confused.
I'm sure what to optimize for.
Right. But when the principle explicitly prioritized one goal, accuracy only, performance shot up. The lesson is, be clear about your priorities. Don't be vague.
Okay, clarity and priorities. What else?
Clarity and structure in the principle itself, just listing objectives like be accurate and concise, sometimes performed worse than even vaguer principles.
Worse. Why?
Possibly because it's still ambiguous how to trade them off. The biggest gains came from principles that provided structured rules. For instance, if inaccurate, the response is undesirable regardless of conciseness. Among accurate responses, prefer the more concise one.
Ah, like giving it an if-then rule, a clear decision process.
Exactly, like a flowchart instead of just a wish list.
Yeah.
It helps the AI navigate trade-offs much more effectively.
That makes total sense. Okay, so knowing what makes a good principle, how did RewardAnything fare on its own benchmark, RayBench, against those unseen principles?
On RayBench, it did really well. Its principle-following ability was comparable to powerful general models like GPT 4.1. RewardAnything 8B hit 81.9% accuracy, which is right up there with GPT 4.1's 82.5%.
Wow.
And remember, this was on novel, diverse principles it hadn't been trained on. It showed strong generalization.
That's incredibly impressive for a specialized reward model. So when they did those ablation studies, taking parts away to see what happens, what did they learn about why it works so well? What are the critical pieces?
Yeah, the ablations were very revealing. First, if you remove the principles altogether during training and testing, performance drops significantly. It really highlights how crucial that explicit guidance is.
So the principle is not optional, it's core.
Absolutely core. Second, they compared listwise versus pairwise training. RewardAnything uses listwise, evaluating a whole list of responses at once.
Right, more efficient than comparing pairs.
Much more efficient, yes. Theta 1, LM calls versus theta into for pairwise. But it also allows for finer distinctions in quality. The listwise approach proved significantly better.
Okay, listwise is better. What else?
They looked at the training method, GRPO versus standard supervised fine-tuning SFT. Swapping GRPO for SFT caused the biggest performance hit.
Why is that?
It suggests SFT just tends to overfit to memorize the training examples. GRPO seems much better fostering true generalization, the ability to apply principles to new situations.
So the reinforcement learning aspect is key for generalization. Interesting. Anything else?
One more crucial bit, the importance of reasoning. When they disabled RewardAnything's ability to generate that explicit reasoning during inference.
Even if it still produced scores and rankings.
Yeah. Performance dropped significantly, down to around 73.9%. It confirms that the process of generating the reasoning isn't just for show. It's integral to how the model actually applies the principle accurately. Thinking through the why helps it get the what's right.
Wow. So the reasoning is functional, not just explanatory. That's a powerful combination of efficiency, transparency, and effectiveness. But okay, benchmarks are one thing. What about the real world? Did they actually use this to align an LLM for a practical task?
They absolutely did, and this is where it gets really exciting, I think. They used RewardAnything to align a Qwen 3.8b model that's a specific LLM for quite nuanced safety behaviors.
Nuanced safety. What does that mean?
Well, the goal wasn't just block harmful stuff, it was more complex. They wanted the AI to, 1, correctly refuse harmful requests, 2, minimize over-rejection of safe requests, being too sensitive, and 3, for genuinely unsafe queries, provide gentle, alternative offering responses, not just blunt refusals.
That is complex. Balancing safety with helpfulness and avoiding false positives, how do they guide it?
With a single, complex natural language principle that RewardAnything hadn't seen during its own training. It included things like safety first, but don't be overly sensitive on safe or borderline queries. Also value warmth, appropriate humor to deflect borderline harm, and genuine helpfulness.
That's a lot to pack into one principle.
It is. And crucially, they didn't need to train a new custom reward model for this specific safety task. They just used the pre-trained RewardAnything, gave it this principle, and used it to guide the Qwen model's alignment using about 2,000 prompts.
And did it work? Could the aligned Qwen model handle those complex instructions?
The results were really positive. The RewardAnything aligned Qwen model slightly reduced incorrect rejections for safe prompts compared to the original model and another aligned model they tested against.
Okay, so less overblocking.
Yes. And, maybe more impressively, for the unsafe queries, it successfully transformed more of the necessary refusals into those constructive, empathetic alternatives providing responses they wanted.
So safer and more helpful.
Exactly. It maintained safety, but did it in a much more nuanced, user-friendly way. And on top of that, its overall text quality, measured by MT Bench, significantly outperformed the other models.
That's fantastic. It really shows the practical power.
It really substantiates this idea of a new paradigm for LLM alignment. It shows you can flexibly steer models towards complex behaviors just using natural language specs. It truly lives up to the reward anything name and seriously lowers the barrier for creating customized, deeply aligned AI.
What an incredible journey we've taken then. We've really unpacked how RewardAnything tackles the big limitations of traditional reward models, the rigidity, the hidden biases.
Making alignment potentially much more flexible, controllable, and efficient.
Yeah, letting natural language principles be the driving force. We saw its strong performance on tough benchmarks, and just now, its real-world impact aligning an LLM for tricky safety nuances.
It's promising stuff.
It really makes you think, doesn't it? So, stepping back, what kind of principles would you, listening right now, want your ideal AI to follow? This research strongly suggests the future of AI alignment might not just be about more data or bigger models.
But about the clarity, the nuance, the quality of the language we use to instruct them.
Exactly. The power, it seems, is increasingly in your words.